Today, I want to talk about objective. First, to investigate the relationship between force, mass, and acceleration. Second, to determine the acceleration of an object under a varying force.
For theory in this experiment, for Newton's second law of motion state that force is the product of mass and acceleration. In this experiment, two masses M1 and M2 are connected by a string. M1 is on a smooth table while M2 hang off the edge as shown in the diagram. When M2 is released, both masses accelerate together because they are connected by the string. The acceleration of both masses are the same, and the string is assumed to be massless and inextensible. Further forces acting on M1, tension in the string pull it horizontally, while on M2, gravity pull it downward, tension pull it upward. Using Newton's law, we can write equation for the force. For M1, T equals to M1A. For M2, T minus M2G equal negative M2A. M2G minus 3 equal to M2A. For combining this equation give the acceleration of the system. G act as acceleration due to gravity. To find acceleration experimentally, we can measure the time using the kinematic equation of linear motion displacement. S equal to ut plus half 1.5 at square. So we rearrange the given kinematic equation. It's gonna be turns out A equals to 2s over t square.
Hi, my name is Wanurin Shaira binti Wan Azmi. My student ID is 2025163573. So I'm gonna talk about methodology that include apparatus and procedure. So the apparatus that needed in this experiment are air track rail, air blower, flat end gliders, and the masses, photo cage, pulley, and the mass hanger that attached with a pressure tube by a string, and the last one is timer. Next is a procedure. The first one, the linear air track set was assembled as shown in figure 4.3. Second, the pump was switched on and air was allowed to blow through the track for several minutes. The track was balanced by adjusting the screws on the legs so that the glider remained stationary and did not glide to either end when released. The third one, a hook was inserted at one end and a flag was placed on top of the glider. Fourth, the mass of the hanger and the mass of the glider were measured and recorded. Then, the length of the flag was measured. 5. One end of the string was attached to the hanger and the other end to the glider. Then, masses of 20 grams were placed on the hanger and 80 grams on the glider. The string was placed over the pulley. 7. The glider was positioned exactly before the photo cage. It was then released and the time shown on the photo kit was recorded. Note, in order to prevent the masses from crashing to the floor and scattering, the glider was caught by hand before the hanger reached the floor. 8. Step 7 was repeated 2 more times to obtain average time values. Then the slotted mass on the glider was then decreased by transferring a mass of 20 grams onto the hanger. Step 7 and 8 were repeated. The last one, the procedure was repeated 3 more times with 20 grams of mass from the glider being added to the hanger each time.
Alright, now let's get the result. So length of flag as x, mass of glider and flag as m1, mass of hanger as m2. So total of started mass on glider as ma, while the total of started mass on hanger as mb. So both is in kilograms. So time taken as t, square of time taken, t square. Total mass of glider as total mass mt1, which is m1 plus ma, also in kilograms. Then, total mass of hanger and total mass mt2 equal to m2 plus mb, also unit in kilograms. After that, weight of hanger and total mass is F equal to mt2 g, which unit in Newton. And the last one is acceleration, which A unit in ms minus t.
Okay, so now we're gonna talk about analysis question 1. What is analysis question 1? Analysis question 1 is plot a graph of weight, force Fn versus acceleration ms negative 2. Okay, this graph weight, force Fn versus acceleration ms negative 2. The graph I got gradient, maximum line, minimum line, and so on. Question 2. What does the graph tell us about? The answer is the graph tells us that acceleration increases when the force from the hanger mass increases, confirming Newton's second law. It also shows that reducing the total system mass by moving weights to the hanger further boosts acceleration, though small errors may cause like deviations in the data. 3. Determine the gradient m of the graph. My group got gradient m in my graph is 0.04 kg. Okay, question 4. Calculate the uncertainties of gradient m. First, I calculate the central point and I got the answer this. Second, I calculate m maximum and I got this answer. And third, I calculate m minimum and I got answer 2. And lastly, I got uncertainty m, which is the formula is half m maximum minus m minimum, and I got 0.01 Newton. Okay, question 4. Calculate the uncertainties of gradient m. First, I calculate the central point and I got the answer this. Second, I calculate m maximum and I got this answer. And third, I calculate m minimum and I got answer 2. And lastly, I got uncertainty m, which is the formula is half m maximum minus m minimum, and I got 0.01 Newton.
Okay, so now I will continue with discussion. So this experiment studied the relationship between force, mass, and acceleration using Newton's second law, F equal to ma. The glider hanger system was used with acceleration measured via photo gas. The results show a linear F versus A relationship with a gradient of 0.04 kg, matching the system's total mass. However, minor discrepancies occur, likely due to parallel errors such as mislight for the gas or an uneven air track, affecting time measurement and acceleration calculation. To improve accuracy, ensure proper photogate alignment, label the air track precisely, and repeat measurements many times. These adjustments will reduce errors and better verify Newton's second law. Yes. So now we move to discussion for the question 1. So percentage difference between gradient and m and total mass mt. So m minus with mt and divided by m plus mt over 2. Then multiply with 100%. Then we will got 28.57%. And percentage error, as you knew, 0.04 minus with 0.0t and then divide by 0.0t, multiply with 100%, and we got 33.33%.
Discuss the factors that have contributed to the errors in the experiment. First, air friction. Although the air track is designed to minimize friction, residual air resistance can still affect the glider's motion, resulting in a measured acceleration lower than the theoretical value. Second, air track imbalance. If the track is not perfectly level, gravitational component may unintentionally affect the glider's motion, either increasing or decreasing acceleration. 3. String and pulley resistance. If the string is not completely massless or the pulley is not perfectly smooth, additional resistance may influence the acceleration readings. Explain how to overcome the factors mentioned in 2. First, minimizing air friction. Ensure the air track is clean and free from dust or debris that could increase friction. Adjust the air pressure to an optimal level to maintain a smooth glider motion. Second, ensuring air track levelness. Use a spirit level to check and adjust the track's balance before experiments. Regularly calibrate the track to eliminate any unintended gravitational effects on the glider. 3. Reducing strings and pulley resistance. Use a lightweight, low-friction string such as thin nylon to minimize mass effects. Ensure the pulley is smooth and well lubricated to reduce rotational friction. If possible, use a pulley with low inertia bearings for smoother motion. Okay, first we're gonna talk about conclusion. First, the experiment confirms Newton's second law, F equals ma, demonstrating that acceleration is directly proportional to force and inversely proportional to system mass. And second, transferring mass increases the force m to g, resulting in higher acceleration as measured by acceleration equals 2 multiple x half t square, consistent with theoretical A equals m2 half m1 plus m2 multiple g.